Search in array. Searching in an array is the process of finding the position of a particular element in the array. If this is the array you are having and you want to find whether one particular element is present in this array or not, how are you going to do this? If you want to do this search, you will start from the first element of the array. You will compare and verify whether this is the element you are searching for. If it is, you will say, yes, I have already found the element. Otherwise, you will move on to the next element. Again, you will do the same check. You will check whether this is the element you are searching for. If it is not, you will move on to the next. Likewise, you will continue sequentially and move till the end of the array. That is, if you are able to find the element somewhere in the middle, then you will stop it then and there, saying I have already found the element. Otherwise, you will move sequentially till the end of the array. If even after reaching the end of the array, you are not able to find the element, that is when you will say the element is not present in this array. Let us take few numbers and see how this is actually working. If this array is filled with these numbers 5, 10, 7, 20, 11, 30. If these are the elements, let us say you want to search for 11. How will you search for 11? You will start from the first element. You will compare whether 5 is equal to 11. It is not equal. You will move on to the next one. It is 10. Again, not equal to 11. You will move on to the next one, next one, next one. And finally, you reach the position where you are able to find 11. What will you do now? You will return the position of this element. What did I mean by position? Array will have indices. Array will be indexed starting from 0. See, you can index it starting from 1 as well. Generally, we do 0 indexing. 0, 1, 2, 3, 4, 5. These are the indices in the array. If you return saying at 4th position, you are having the element 11. What is the advantage now? If anyone wants to directly access the element 11, you can directly say array of 4. This will directly give access to this particular element. This is how searching is done. Let us write a pseudocode for this so that in case you want to write a program for this, you want to implement this in a computer, it should be easy for you. That is why we are writing the pseudocode. Let us say you want to search in the array for a target element. I'll write target. This is the element you are searching for. Array is this array in which you want to do the search. What is the pseudocode? Pseudocode means it's not strictly adhering to the rules of any particular language, but this will be similar to the general rules used in all the languages. So you will easily able to convert this into any particular language. This is the use. What should you do? How should you search in this array? You should start from the first element and go till the last element. How can you write it? You can write it as for, you're writing a for loop, I is equal to 0 to, what is the last element? You want to find length of array minus 1. Why am I writing minus 1 here? The reason is indexing of array is starting from 0. For example, if you take this array, length of array is 6. There are 6 elements in this array, but the last index is 5. So length of array minus 1 will be the last index. You will start from 0 and go till length of array minus 1. What should you do at each element? You need to compare whether the element at that position is equal to your target. How will you do that comparison? You should write if statement. If whatever is the element present, a of I, if this is equal to target, what should you do? You should return the index. Index is I. Otherwise, if after completing this whole for loop, you are not able to find the element, that is you didn't return even after completing for loop, that means the element is not present in the array. What should you do then? You should return minus 1. This is the pseudocode for searching. Next question is, what are the time and space complexities of this algorithm? Time complexity, you can say that in the best case, you can solve this in order of 1 time, that is constant time. How is it possible? It is possible because if the element you are searching for is the first element itself, let us say you are searching for 5 in this array. First element itself is 5, so in constant time you will complete it. But whenever you are asked about time complexity, you should never think of the best case. This is never a good approximation. You always want to see what is the worst case. If everything goes wrong, then what is the worst case scenario time complexity? This is what you should always be concerned of. So if anyone asks you what is the time complexity of any algorithm, you should always go for the worst case scenario. So in this search, what is the worst case scenario? What can happen if nothing goes your way? In that case, the element you are searching for will be present in the last entry, the last element. For example, here, if you are searching for 30, what happens? You will start from the first element. You have to go through all the elements and finally you will reach 30, which means if n elements are present in the array, then you have to go through all the n elements in order to complete your search. So your time complexity is order of n. This is the worst case time required to search in an array. What about the space complexity? Coming to space complexity, you only need to consider that space which is additionally used by your algorithm. For example, in this case, there is an array that is already present. This won't count in your space complexity. The reason is this array is already present there. For searching, are you using any extra space? This is the question. If you see this, what did we do while searching? We just went through each of the elements. We did not occupy any additional space. So the only space is constant space. You can say order of 1. You can do this in constant space. There is no additional space used. So the time complexity is order of n and space complexity is order of 1. One more thing is, in case your array is sorted. Here we just took a random array. Instead of this, if your array is sorted, you need not go through each element one by one. Instead of that, you can use binary search. How is that done? If you want to do binary search on the array, the condition is array should be sorted. So instead of this, if the array looked like this, let us say 5, 10, then it is 15, 21, 27 and 30. If this is the array, then you can do binary search and reduce this time complexity from order of n to order of log n. How can you do this? Because it is already sorted, you will directly go to the middle element. You will see the element in the middle and then you will compare the element you are searching for with the middle element. In case it matches, well and good, you will say I've already found it. Otherwise, the advantage here is if the target element is larger than the middle element, then you are sure that if it is present in this array, it will be present in the right side. In case your target element is lesser than the middle element, then you know that if the target is present in this array, it will be present in the left side. Which means in each step, after comparing with the middle element, you can directly remove half of your array. This is the advantage. Whenever you can decrease the total by half in each step, that is when you get a time complexity of log n. So how you can see this is, in case you can somehow see it as exponentiation and logarithm, these are the opposites. See, this part that I'm going to explain regarding time complexities, we'll explain it in detail in the coming lectures, but whatever we are saying here, just take it as a basic explanation. This is not the actual explanation, but using this, you will be able to directly tell the time complexities in certain cases. That is why I'm doing this. You can see logarithm and exponentiation as the opposites. That is, in case something is growing like 2 into 2 into 2 into 2, this is what you call as exponentiation. If n times it is growing, you will say it is 2 power n. This is exponential time complexity. Instead, if it is a case where your total, for here it is search area. If your total search area, it is getting decreased by 2, by 2, by 2 and so on. If it is getting halved in every single step, then you will say it is order of log n. Exact explanation we'll do in the coming lectures because it will be heavy to start with these things. As of now, just understand like this. It will help you in directly finding the time complexities. We'll explain in detail the mathematics in the coming lectures. So in case of binary search, you can do it in order of log n. What I'll do is I'll tag linear search and binary search lectures with this. You can go and see the for exact details and on how these searches are working. So in general, if you ask you how to search in an array, what is the time complexity? It is order of n and it is for linear search. If it is sorted, then you can use binary search and bring it down to order of log n. So in general, time complexity is order of n, space complexity is order of 1.